UCD, we have discussed that before the break, is deferred periods utility or contemporaneous utility. We assume, as a standard, that it is increasing and continuing. So we have positive marginal utility, and we have decreasing marginal utility. Our consumer is risk averse. To keep things simple, we will make different assumptions later on. To keep things simple, we assume that the discount factor, that's this beta, that tells you how much our consumer discusses future consumption, that this beta is equal to 1. That basically means that every utility function, every period, gets the same weight. What we will typically see later on is that beta is smaller than 1. Okay? Which means that basically further into the future, the further into the future you go, the less weight utility gets. What we capture here, we capture, when beta is not equal to 1, we capture invasions. People prefer to consume now as opposed to sometime in the future. So typically beta will be lower than 1, which we capture invasions. The lower beta is, the more our consumer focuses only on today. Because you have this power T. So if you are far in the future, you have a number between 0 and 1, this weight becomes very small. We'll talk about that later. For now, we assume that beta is equal to 1. What does this mean? It means that this person gives the same weight, 1, to every period. So consumption far into the future has the same weight as consumption tomorrow or consumption today. That's for simplicity. Later on, we will look at something different. The individual consumer is born with some endowment, A0, in period 0, which can be valid, and will receive an income, IT, for every period now and in the future. So, when we look at this problem, we have a budget constraint. We make an additional assumption here, that is that the interest rate, the real interest rate, R, is also equal to 0. Again, we will relax this assumption in a while, but for now we keep things simple. So what does it mean? With an interest rate that is not there, you don't discount anything from the future. Future amounts, future income, normally you would discount it by 1 plus R. You don't do that here. So that means that the budget constraint in this case is very simple, and it looks like this. What do we see here? That's a sum from 1 until period T of consumption. And of course, to satisfy the budget constraint, our consumer can only consume as much as he or she will earn. And what is the earnings? It's the initial endowment, A0, plus all future incomes. Usually we assume that equality holds, right? Because why would someone consume less over all life years than all the stream of future incomes? Usually we put an equality sign here. Bequest. We don't talk about that here. Okay? You can have bequests, then things get more complicated because you want to release something from future generations. We don't talk about that here. We keep things simple. But in that case, of course, you would also have a different setup. Now, we keep the analysis simple here. We just want to know what is optimum. Well, our consumer has to solve a problem that is to maximize lifetime utility subject to the intertemporal. We call this intertemporal budget constraint. So how can you do that? You maximize the Lagrangian with respect to consumption in every period. So you will have a maximization problem with respect to consumption in T, with respect to consumption in T plus 1, and so on. Well, we only need to solve maximization problem once to know what the output looks like. And in this simple case, where you have beta equal to 1, interest rate equal to 0, no requests, no complications, the solution is very easy. You have that marginal utility will be equal to your constant Lagrange multiplier lambda. What do we see in the optimum? In the optimum, marginal utility of consumption will be equal in every period. Marginal utility in this this case, consumption of uncertainty is equal in every period. What does it mean? It means that if we make the assumption that utility functions are the same in every period, which is what we do here, we assume the same utility function in every period, that means that consumption should be constant as well. Consumption will be the same in every period. Now, what do we call this? This is the consumption smoothing result, which says that it is optimal for the consumer to smooth consumption, to keep a consumption profile that is as equal over time as possible. When you have consumption that is equal in every period, you can substitute this result into your budget constraint. So you get the same CT in every period. You can put that in here. Assuming that the budget constraint holds with equality, you can write down a consumption function that tells you that consumption in period T equals 1 over big T, the amount of periods that a person lives, times initial wealth plus the sum of all current and future income. So our consumer consumes a constant fraction of lifetime utility, which is known as permanent income. Lifetime income, sorry, which is also known as permanent income. So this term here is called permanent income. So, looking at this very simple theory on consumption, basically the standard consumption theory, until quite recently, because nowadays people don't use permanent income anymore as the standard benchmark for consumption, but they use buffer stock type of models, which we will discuss next week. But until very recently, this equation was the standard benchmark model for consumption, even though it was extended to account for uncertainty. Later today, we will look at a similar equation which also deals with uncertainty. Remember, here we assume that people have certainty. What do we mean by that? We mean that they know their future income with certainty. So they consume based on this calculation, and they know the future incomes they will have. Later on, when we have the case with uncertainty, we'll assume that they don't know future income. So they have to form expectations about future income. But in this simple case, we assume they know everything that they will earn now and in the future. Now, conclusion. According to the permanent income hypothesis, consumption depends not on current income. Current income would be just IT, but it depends on this sum, this average of current and future income. This we call permanent income. Difference between permanent income and current income can also be looked at. So what is the difference between current income and permanent income? This whole term, we call that transitory income. That's something that is unusual. You get one period you get a bit higher in income, next period you get a bit lower than your permanent income. We call that transitory income. So this simple model where you see that consumption is based on permanent income already provides us with an explanation for what we saw at the beginning of the lecture. At the beginning of the lecture, remember, I showed you the figure where we could see that consumption is much less volatile than other GDP components. I told you that consumption is much less volatile, for instance, than investment. Well, one reason why that is the case is that according to the permanent income hypothesis, consumption is not based on current income, which could fluctuate a lot, but rather on this average of income, which will fluctuate much less, because it's an average. So all transitory variability will be out of there. So permanent income hypothesis can explain why consumption varies relatively little, because it's based, consumption according to this theory is based on permanent income, which is much less variable than current income, actual income. Now, another implication of the theory, because we're interested in consumption, its counterpart, consumption saving? Well, saving is always equal to current income minus consumption. That's always true. What you don't consume, you save. Income minus consumption. Well, consumption equals permanent income, so you can write saving as this. Well, what does the permanent income hypothesis tell you? It tells you that when current income is high, and by high we mean that it's relatively high compared to your permanent, your average income, then you will save this. And when current income is low, lower than your permanent income, you will dissave. That means that you will borrow or you will build up, decrease your wealth. Dissave or borrow. So what does this basically tell you? That people are using savings to smooth consumption over time. When income is high, people don't consume that, they save. When income is low, people dissave. And consumption always follows your permanent income. So consumption is very smooth, and saving and dissaving helps to keep it that way. So immediately you can already see that once people are not allowed, for instance, to dissave, once people are not allowed to borrow, for instance, the permanent income hypothesis will be in trouble. So one of the main assumptions is that, according to the permanent income hypothesis, for people to be able to smooth consumption through saving and dissaving, of course they have to be able to do that. And if they, for instance, don't get credit, for instance, when they want to borrow, that will make it hard for them to smooth consumption over time. In that case, that's the liquidity constraints case, people will be forced to base their consumption not so much on permanent income, but more on current income. But that's for later. Now, let us take a look at the number of empirical implications of what we have seen. So, empirical implications that tell you something about the type of consumption function that we can observe in reality, in the data. Well, Keynes argued that aggregate consumption depends on current income. So, the permanent income hypothesis is from basically Friedman and Modigliani, which did the life cycle hypothesis. This is from later. Keynes had a very simple vision of consumption. He argued that consumption is proportional to income, to current income. And people have a marginal propensity to consume that lies somewhere between 0 and 1. So the consumption function, typical consumption function, Keynesian consumption function, looks something like where beta is the marginal propensity to consume, lies somewhere between 0 and 1. That's your typical Keynesian consumption function, where current income drives consumption rather than permanent income. Keynes also, now, the reason Keynes came up with this is not because it's not true, right? So, there is a reason why he came up with this. That's because he saw it in the data. Based on certain observations in the data, he came up with this relationship. So this is not false. However, at first sight, it seems that it's not in accordance with our permanent income hypothesis, which states that consumption should be based on permanent income instead of current. So can we reconcile Keynes' ideas with the more modern version of consumption, which is the permanent income hypothesis? So that's what we try to do now. Another observation from Keynes, for instance, was that if people get richer, or if they have a higher income, they will consume an ever lower fraction of their income. They will save an ever higher fraction of their income. So another, besides this consumption function, another observation made by Keynes was that as people earn more, the fraction of their income that they consume tends to fall. That means that the fraction of their income that they save rises. So that's another observation, which we still observe today, by the way. So we're trying to reconcile these empirical observations with the permanent income hypothesis. Well, several empirical studies have been conducted to look at the relationship between consumption and current income. And some people argue that if you look at households at a given point in time, you find that the relationship appears to be of the type postulated by Keynes. This is what Keynes suggested. That consumption function looks something like this. Much flatter than the 45-degree line. The 45-degree line tells you C equal I, or C equal Y. Now, for the Keynes, the consumption function looks something like this, with beta somewhere between 0 and 1, but definitely not 1. Now, other studies tell us something else. Other studies, particularly time series studies, within a country over time, show that aggregate consumption is instead proportional to aggregate income. So according to these studies, who don't look at households at one period of time, but who look at time series for one country, they claim that consumption is, in fact, very close to current income. C, according to these guys, C is very close to current income in every period. Now, can we explain these different empirical findings with our basic permanent income hypothesis? That is what we want to do next, what we want to look at next. So, can these facts be reconciled? Can we, with the permanent income hypothesis, explain the different findings? On the one hand, the findings for different households, and on the other hand, the time series studies. Well, the permanent income hypothesis tells you that consumption is determined by permanent income. So we say that CT is equal to YPT. I told you that this can be written as 1 over T times wealth, initial wealth, plus the sum of all incomes. And current income is equal to transitory income plus permanent income. So, what else do we need to know? Well, in most samples you will see that transitory income typically, on average, equals 0. So transitory income, what is it? What is it? I mean, one day you get a windfall gain, the other day you get bad luck, but on average it tends to 0. So you have a positive income shock one day, you have a negative income shock another day, and the sum cancels. So on average, transitory income is equal to 0. Another finding from most samples is that permanent income and transitory income are not correlated. So there is no real correlation between permanent income and transitory income. They stem from different sources. Now, what do people typically estimate in the empirical literature on consumption? Well, they estimate something of this type. They link consumption to current income. So you have consumption is equal to constant, beta 0, plus a slope, beta 1, times current income, plus what you typically add in the regression equation is an error term, which you assume has a 0 mean. People have been estimating this type of consumption functions. And so, before continuing, you should ask yourself what the OLS estimator of such an equation really measures. Well, if you don't remember that, take a look at your statistics or econometrics course. Yes?
Do they look at the aggregate consumption, so the total, or just on a household level?
At this point, we're basically looking at macro data. So the household level is basically looking at, the time series is the aggregate data. The other studies are looking, for instance, at different households at one period in time. So that could be called micro data. So you have two types of studies.
And another question about the expected value of the transitory income.
Yeah.
How can that not be 0 Because it's defined as 0, right?
Well, it's 0 on average, but it's not 0 in every period.
Okay.
So that's the average of transitory income. You have one positive shock one day, you have a negative shock the other day. Average is 0.
But the expected value is always 0, right? Over the whole
Expected
period.
value is the average, right?
Yeah.
It's 0. That's what people tend to assume, to find. So, and when you look at those different types, this you can call a household study. You can look at households, this, a sample of households, for instance, where you have for a given country, 1,000 households, and according to most findings, you will see that households with higher income also have higher consumption. But it's not proportional. It's this type of relation. This type of studies is time series. You can also look at that for one country, but it's aggregates. And you will see that countries with higher income over time tend to also see their consumption. Now it will become clearer, I hope, when I first discuss what is the OLS estimator of beta. So what is typically the OLS estimator of beta in such a regression equation? It's the covariance between y and c divided by the variance of y. So you have the covariance between y and c divided by the variance of your regression. Now, looking at those definitions here, or those assumptions, those findings, you are going to substitute y for yp plus yt, because income equals permanent component and transitory component. Permanent income hypothesis, which is the model we are looking at basically to explain those empirical findings. Permanent income hypothesis tells you that consumption is equal to permanent income yp. Now you have the variance of y in the denominator, and y is equal to yp plus yt. So then you get to this step. Now you have covariance between this term and permanent income. Well, we argued that the covariance between permanent income and transitory income is 0. So what remains here is the covariance between yp and yp, which is just the variance of yp. So the numerator becomes the variance of yp. And then below, you have the variance of the sum of yp and yt. Now, since the covariance between both is 0, you can write instead the variance of yp plus the variance of yt. So, you can write this coefficient estimate, beta 1, the slope estimate, you can write as the variance of permanent income divided by the variance of permanent income plus the variance of transitory income. As homework, try to derive the constant as well. Try to derive an estimate, OLS estimate for the constant, beta 0 hat. Now what can you see here? Basically when beta is equal to 1, income and consumption are proportional, and the constant will be 0. So you will get this situation where you have basically consumption function that goes through the origin. Of course, in the other case, when beta 1 lies between 0 and 1, this will not be 0. You will have constant to the consumption function as well, and you will be in this type of consumption. Now, important is this formula because we have derived this under the assumption that the permanent income hypothesis holds, and still we will show that it can explain the relationship between consumption and current income, and in different ways. It can display both the Keynesian consumption function, this one, but it can also explain the consumption function that is proportional with the current income. What do we need to look at? Well, we need to look at the relative variance, the variance of permanent income versus the variance of transitory. Depending on how these are, we will end up in either the one situation or the other situation. So, the coefficient for beta suggests that if the variation in permanent income is much higher than the variation in temporary income, consumption will move one-to-one with current income. Well, how do you see that? If the variance in permanent income is very high, then this term will not play a big role, and this will go towards 1. If the variance of transitory income, on the other hand, is the thing that is important, if that is big, this will tend towards 0. So the more important permanent income versus transitory income, the closer beta will go to 1. On the other hand, transitory income is the important part. The variance of that one is high compared to the variance of permanent. The coefficient will tend to 0. Well, that can explain the different findings of cross-section household studies compared to time series studies. In cross-section, in household studies, much of the variation in income across households comes from the fact that households, for instance, are at different points of their life cycle. Some of them may be unemployed, some of them may have bad luck. The variation comes mainly from the temporary component of income. If the temporary component of income is important, beta will be far away from 1. And you will have a constant that is non-zero. You will have consumption function like this. On the other hand, over time, within a country, then we're looking at aggregate time series studies, most of the variation in income is related to growth, long-run growth in income. And that is typically something permanent. So most of the variation in this case comes from the variation in permanent income. If most of the variation comes from permanent income, these are high compared to this, and the slope coefficient will be estimated to lie near 1. And if the slope coefficient is near 1, the constant is near 0, and you end up in a situation where consumption and income are quasi proportional to the other one. So, you can explain both empirical findings, the Keynesian type of consumption function, but also the proportional consumption function, both types of relationship between consumption and current income, you can explain using the permanent income hypothesis, where the basic is basically telling you that consumption is related to permanent income. Okay, so these are, yeah. That's one way to look at it. But the problem with Keynes is that it's postulated the consumption function basically on empirical data, in this case across households. That there was not really a derivation of some optimizing behavior. So, but his observation was right. But then he also said that this should hold, because it held across households. Keynes also argued that this should hold, for instance, in time series. That was not right. So basically, with the permanent income hypothesis, which is based on optimizing behavior, you can explain Keynes' empirical observations, because his empirics were right. But there's more going on than that. And you can also explain things that were not in accordance with Keynes. For instance, the fact that in a time series setting, consumption is roughly proportional to income, which is something Keynes would not have agreed on, because he believed that this would hold in all cases. Good. Let's now go one step further. To keep things simple, we are going to make a new assumption. That is that a person, instead of living T periods, lives only